Okay, welcome everyone to the Tuesday, November 12th Working Group Component Standard meeting. We've got a short agenda this morning, but since Lee and Lubomir were starting to have a conversation about some technical things, maybe we'll just continue that for a minute so you guys can finish.
Sorry, I'll just finish up adding our names to the notes. This is Lee, Nitofin, and Lubomir.
I love your plants, by the way.
Thank you.
Awesome.
They are not explicitly my plants. They are Tanya's plants, but she does have very, very many.
Pretty cool.
And we may not be receiving whatever our security deposit was back on this place because there's also like a pull-up bar that we built. Yeah, that's Tanya. And Pepsi with you too? Oh no, he's just lying down. Anyway, yeah, so Lubomir and I were just chatting about some somewhat unrelated stuff with regard to the end-to-end test suite and machinery for the project, since we're coming up on code freeze and into the release window. And basically, Kinder is an offshoot development tool that we wrote around Kind.
Okay.
And it's used to create like short-lived, lightweight, virtualized environments using containers for the end-to-end test suites. So we are able to do like a Kubernetes HA deployment very quickly with a tool like Kinder.
Cool.
So Kinder will get you like to the cluster. Kinder will get you to the infra without the cluster set up, so you can run end-to-end tests and stuff. But we need to update it basically, and it's been a little bit of a fight with, or just there's been some dependency challenges between the two projects. So.
Gotcha. I need to check that out. That seems pretty cool.
It's super useful. The reason why I was talking with Lubomir about supporting mounts is because I use it like basically every day to spin up almost clusters so that I can do development on Kubernetes. So
that's my biggest gripe about Kubernetes is how long it takes to iterate.
Yeah, I have like a little shell script that like basically uses the cluster config and like just sets up a few nodes that are ready to be used, and it takes like 5 seconds.
So nice.
So it's definitely good. It's kind of the same thing as like using Kind. If you've ever used Kind and then you log into the nodes using Docker exec and run a kubenm reset.
Okay.
So it's kind of a similar effect there, right? Except you don't have to wait for the cluster to bootstrap.
Cool.
But yeah. So I don't know if you had any further comments, Lubomir, but that's basically why that config stuff is important to me personally, is exposing ports and mounts are useful for development.
Yes, so we are facing a problem there that is relevant to this group. I didn't want to bring this as an agenda specifically, but basically including a public type from something that is alpha in your external project and using the fields like Kinder is using with the Kind config is very problematic in terms of maintenance. You have to schedule releases, you have to match the upstream project schedule somehow. We are also trying to match the Kubernetes release cycle. So these alpha v1, alpha 3 Kind fields, it's very hard for us to manage them, and also like supporting the -- config on the command line for this upstream tool it's very difficult for us. So that's why we're dropping this, and it's really, really super related to this group. And also I have another example that is similar to this. Like Coaster API recently started complaining that it's hard to import the kubeadm types inside the Coaster API because the kubeadm types change. I mean, we are beta, but we are still changing.
They working on like decoupling some of that stuff too, or maybe it's still a problem even in their v1 alpha 2?
Yes, so so there is a KubeADM bootstrapper, which is like responsible for basically applying the topology for the KubeADM nodes. And currently what they did is they have a KubeADM bootstrapper config file format. And inside this format, they have pretty much init configuration and join configuration fields. These are types from KubeADM. But they're pinning to a version, which is like v1 beta something. And if KubeADM changes this config for in the future, if this config no longer supports, so if the binary of KubeADM no longer supports this config type, it becomes a problem. So what I suggested there is that they should.
Oh, are they like totally stuck on it? Like they don't have a way of. Yeah, I see what you're saying. So you'd have to rev, if they no longer support it, you have to rev your config version.
Yeah, it's pretty much the same if V1 core V1. If you develop the client based on client goal and you're using core V1, and suddenly Kubernetes has core V2, you have the same problem. You have to update your whole logic.
Yeah. V1 to V2 is more challenging. V1 to extensions of on top of V1 that are still V1 shouldn't be as hard, right? Because you just import those and get the same extensions.
Yes, it should be easier for extensions.
So it sounds like at least so in the case of alpha stuff, yeah, it's totally a problem. I don't know if there's a good solution because that stuff is guaranteed unstable.
So I just want to understand the problem a little bit better if we're just bringing up something that already exists. Because for me, if you are using a particular version of Client Go or kubectl, like kubectl, its default mode for the core API is to use the Go implementations of the types. Like it's not just constructing stuff on OpenAPI. So I mean, if you're using like an old version of kubectl with the new version of Kubernetes, it probably works for most things because Kubernetes API machinery has backwards compatibility support. And there's like totally like a shifting of there's like no guarantees there that people are actually supporting from 6CLI, but it works because we have the old types.
kubectl, right? Like if you so where it shows up in kubectl is if you add an altogether new API group or an altogether new kind to an existing API group, old kubectls can't recognize that at all. And if you add a new version of an API group that is not compatible conversion-wise with an old version of that API group, you have the same problem, right? So if you go from like V1 to V2, I guess no, that's actually, we still say we'll do conversions for Kubernetes there, but
it happens from the API server, right? Because they negotiate.
Yeah. That's not actually a problem.
But the API server is what supports the old types, right? So
there is actually a problem if you have a really old version of kubectl, and we've gone so many versions in Kubernetes. Say we've gone like V1, V2, and V3, and then we had all those concurrently, and then we chopped V1 and just had V2 and V3, and you're using a really old kubectl that only understands V1, then you're in trouble.
Yes, right, because it's just not going to work at that point because you're out of the support matrix of what APIs we serve.
And the solution to that is to use a newer kubectl.
Exactly. So my understanding of that, right, is that is like one of the major functions of API machinery is that we can eventually deprecate things, but we have a sliding window where we can support older APIs. Right. So to me, like if Cluster API wants to build things based off of, V1 beta 2 KubeADM types, then they've got a sliding window, right, to keep updating that so that KubeADM binaries that are serving that API right? Like still support them for a period of time, and then they move the project forward. And if you're using an old version of Cluster API that supports an old API and KubeADM doesn't support that anymore, man, like fix it, right?
Yeah, I think that there's a challenge though, right? Like um, upstream projects that people are taking dependencies on aren't moving their APIs forward quickly enough. And so they're in these like not great stability situations. And then people go, well, I want to build something on top of this. And like they're not going GA anytime soon. So I'm just going to use the alpha. And like then they, you know, later it's like, oh, well, this is really painful to use the alpha. Which is true. So I think like some of this actually falls on those upstream projects to like graduate their APIs more quickly so that they have a lot of interest in the project, they can get out of an alpha state and offer stability that makes it less painful for people to build on top of them.
Yeah, something I proposed to this particular problem with the cluster repair, I pretty much said that they should stop embedding the KubeADM types inside the cluster API KubeADM Bootstrapper type, because this is essentially version pinning, and instead they can use references. So you can feed the name for the metadata, and then use a Google, the JSON multi-doc or something like that to specify the KubeADM config at the bottom of this cluster API Bootstrapper config. And what this is going to do is that you're not pinning. If the KubeADM config is out of date, it's the responsibility of the user to update it and pretty much patch this multi-doc. But this is now a YAML problem. It's not a problem on the side of the KubeADM Bootstrapper config.
Yeah.
So I like that. Using object ref like makes sense to me, that it would be keyed by kind, and then it would go resolve the API group and version at a later time through the API server. The only comment I have is that we added object meta support to the types, I believe, this cycle in KubeADM, and that was purely mechanistic. It wasn't intended to be user-facing, but something like that, whereas if you want to actually object ref to a KubeADM config in like a multi-doc YAML, like you're going to want to, you open up the use case to have multiple KubeADM configs in there, and they'll probably need names, and you probably want to be able to object ref them by name.
Yeah, even if you stuck them in a config map, like that would be sufficient, right, to get the late binding on the versions.
You're talking about like just using a string field of some sort for the init configuration and not actually having it be typed?
Well, it can be, I think it gets really tricky because I don't know, first of all, what needs to parse the KubeADM configuration. If it's just KubeADM, then you just have to plumb it to KubeADM. If there's something in the cluster API that actually needs to parse it and do stuff to it, that gets a lot more complicated because then it does end up needing to know some version. But if it's opaque, then they shouldn't embed it.
So it actually depends, but one thing is for certain, the object meta does not get embedded in this cycle. So we still don't have any ability to basically distinguish between different objects out of the basic KubeADM types. And another way to basically try and treat this is to basically just stop embedding the type inside of the cluster API types by simply like replacing it with a map. So a user will be actually embedding the same type again, but as a string block, sort of the way that the config maps actually do this. So this way we actually won't get any sort of validation or stuff like that, but at least, or we are going to have to write things down. So we don't have to, we don't get these automatically. But I think that the problem here is a little bit more like it's shared between different components. So for example, in KubeADM, we were facing sort of a similar problem with component configs. So the problem here is what do we do with the component configs that get obsolete and we need to upgrade them, and we aren't actually the component, we are something that provisions them. And in our case in KubeADM, these components are usually kubeproxy, kubelet, whatever. But in Cluster API's case, these components are like KubeADM and other stuff. So the problem just shifted.
Yeah, but for KubeADM, we support conversion on the command line. That's the difference. Like going back to the old discussion about components exposing conversion. We support the conversion, so if the user feeds this old configuration in the Cluster API Bootstrapper config, with a map or a multi-doc, if they feed this config to the KubeADM binary, the KubeADM binary can potentially first try to convert it to the preferred version. If it's in the, this is in the supports queue still.
Yeah, which is basically like KubeADM, we're trying to basically save folks from having to go around the YAML manually and do some sort of conversion, or even type up some scripts to do this automatically. And other components aren't doing this.
I see. So yeah, so other components, what are other components? I mean, KubeADM is interesting because it's sitting in between, but I assume the conversion you're talking about is conversion of KubeADM's API, like component config types, right?
Yeah, and if a user wants to upgrade, right, from
Not,
version of a type to the
yeah,
beta.
not the end components.
But yeah, I mean, basically what Ross is referencing is that people have that same exact use case if you are working with the kubelet configuration.
Right, but those end components should also do the conversions. Like they should, or they don't have to necessarily convert and write back out, but they need this support queue.
So
In
the
Kubelet, we'll do
conversation that we've had
right.
With regard to this is that there's two answers. One is that you either allow people to work with the internal types and the defaulting and conversion functions somehow without having to import the entirety of Kubernetes. And then that is, you're baking those types into whatever project binaries are using those types, or you have a standard CLI interface that you can shell out to for any component that does component config stuff.
Yeah. That was the more advanced version of this use case, right? That was like something like KubeADM wants to take somebody's old types and then use the new component binaries to upconvert them. So KubeADM can automatically keep someone within the support SKU. But in this case, I think it's just that we want to make, like, if there's some meta machinery that's plumbing configuration through to end components, it's best that that meta machinery not couple itself to specific versions of those component configs, and instead just let the components upconvert when they parse the end config.
So yeah, basically that advanced use case that you're talking about, I was not talking about. Okay. The whole like automatic converting on a user behalf thing, in my opinion, is actually dangerous. Not that we can't build things in KubeADM for users to explicitly do those things, but the standard CLI interface is rather the atomic unit of like, well, this component has a component config, and there exists zero tools to actually upgrade, right? So from a user standpoint, you need something that you can actually, otherwise you're just handcrafting, 200.
Right. You need something that will write out the new version
So for the kubelet, the authority on that API and the most likely thing that will have all of the versions that you're actually using is going to be the kubelet binary you're using, right? And so if the
Yes. The question is like whether the kubelet binary just does that automatically, or
so
whether somebody has to call it. And if
there's nothing that can be done automatically to upgrade a user's config file. Like at some point, the kubelet will stop supporting Alpha 1, right? It'll
well,
be
it's beta 1, but yeah.
well, yeah, but V1 Alpha 1 like will no longer be supported in the kubelet binary, which means
Sure.
that you can't just pass it a V1 Alpha 1 config. So at some point, the user needs to take their alpha config and get to a newer one.
Yes.
And it's ideal if a user doesn't have to do that by hand. So there needs to be some tooling that has ownership of that API
Yes.
that allows the user to take their config and actually get to a more upgraded version so that they can pass it to a future version of the kubelet.
Yeah. So I think there's a couple things. Like one, I want to like go a little bit bigger picture and look at how I've seen these things typically configured is that there's basically like a cloud provider running a service, and they're responsible for like deploying the next version of the service with the right config, and they can pay someone to like manually figure out what like the new version of the config should look like and then automate that before that version releases. And I think that same paradigm might be true with like kubeadm, right? Like if you say kubeadm upgrade me to next version of Kubernetes, like, and I spin up the new nodes with the new configurations, then like the user is not in that path of having to manually edit. Although the kubeadm also embeds a lot of stuff about the configs, and so that makes it maybe a little more challenging.
Yeah, this is
like cloud providers typically expose many fewer options, so it's maybe easier for them to abstract.
Yeah, so it's much more easier for cloud providers. Kubernetes basically has to export the whole type of the component config to like the user, and this is much more difficult to translate into the new version. So basically, what I'm proposing in the already merged KEP for Kubernetes component config strategy is to basically whenever such problem is detected, so an old version is deleted, and we have only the old version, and this is basically a user supplied component config, which was basically not generated by Kubernetes. We ask the user to go and manually replace that component config, so sort of edit the config map. And if the component config was actually generated by kubeadm, then we just scrap it and generate a new one.
Right. Yeah, and I think it sounds like sounds like kubeadm needs to be the caller of whatever, tool we invent to do these up conversions.
Yeah, so it's going to be like the consumer, but the caller is not guaranteed to be only kubeadm. It may be even end users and
Sure.
cluster API, whatever. And actually, this actually sounds pretty similar to the validation KEP, which is not merged right now, and it's pending discussion. And it basically proposes the same interface, but for validation. And kubeadm currently, we want to use that interface should it be actually accepted and implemented in some components.
Okay, can you link that in the meeting notes?
Yeah, just to find the existing KEP PR, which is the validation.
Interesting. I think we can't solve this for the alpha transitions because those are not guaranteed to automatically convert, but we can for beta and beyond.
I mean, it's usually a choice of the component itself whether they should support the alpha transitions. If they want to not break the users, they can still implement the conversion and support the the alpha 2 to alpha 3 in a safe manner.
Yeah, I like in practice, yes, components can do that. I want to be careful to set user expectations appropriately as well. Like there's no formal policy that says, for example, a component that was supporting alpha transitions must continue to support alpha transitions. Like,
Yeah, that's definitely a decision on whoever's implementing the final form of the API machinery. But that it is good to point out what
I don't want to.
bring
Sorry.
up. It's more of a social and like informational limitation than it is a technical one.
I want to leave that option open to whoever is implementing the component, because the reality is that as much as like it, we need to set user expectations appropriately, but sometimes important things get built on unstable APIs, and we also need to be able to see the reality and implement backwards compatibility in those cases when it happens. Even if it shouldn't happen, sometimes it happens. So.
Is this actually part of the API machinery deprecation policy document that there are no guarantees for up conversion to the next alpha?
Yes, I believe it is. I don't know if it's that explicit, but I'm gonna pull it up.
Because there's an example table below, and it has some examples from alpha transitioning.
Yeah, the examples look like they actually just yank V1 Alpha 1 and tell people that they need to manually convert to V1 Alpha 2 in the release notes. Those first two lines of the table.
Folks, I think that we're at the top of the hour, and if this is the C cluster lifecycle.
Okay, all right, let's get out of here. KubeCon's next week. Hope to see folks there if anyone's going. Lee and I will both be there representing the working group. Take care, everyone.
Bye-bye.
Take care. Bye-bye.
Thank you.